So since this is inverse trig, the first thing I like to do is take it out of inverse trig and write it as circle trig. Oh, sorry, I need the theta in there. Sine of theta is equal to 1 over root 2. Are these the same thing? No. This one's got restrictions. This one would be circle trig and wouldn't have restrictions. So what does that mean? That means when you draw your little circle, your circle trig, you should have said, since this is inverse sine, it's only allowed from here to here. That's out and that's out. Then, since sine is positive, there's no negatives, it must be here. That's out. And sine is opposite over hypotenuse, and you hopefully will recognize, oh, it's the 1, 1, root 2 triangle. That's the 45 degrees, and that's pi over 4, and that's your answer. Raise your hand if you had pi over 4. Excellent. That was the right answer. But wait, there's a lot more that you might not be seeing here. And I'm not saying there's more like you have to give a different answer, but we said that it's pi over 4. Remember that. Remember, the answer is pi over 4. But I'm going to redo this. Sine of some angle is equal to 1 over root 2, which, by the way, is 0.7. Do you agree that that's, I don't know if you know that, but it's basically 1 divided by root 2 is about 0.7. If I graph that, watch this. Here's sine. Do you agree it keeps going? Right? Remember that? And what if I graphed y equals 0.7? In case you didn't know this, you can graph the left side, you can graph the right side, and then this is what's really happening. How many answers are there really? Infinite. Because it hits right here at 0.7. That's where 0.7 is. 0.7. Right there. And that was, what was the answer again? Pi over 4. Do you remember that this spot right here is pi over 2? That's also 2 pi over 4, and this is 3 pi over 4, and this is 4 pi over 4. And you know what I mean? Like this, just is this the normal numbering system? Why do we only get that one answer? Because do you remember me saying we were only going to go from negative pi over 2 to pi over 2? That's why you only have one answer. It's because it's inverse trig. We're in the green box. Why are you in the green box? Because inverse can only happen on that part of the sine wave. If you flip the entire sine wave, it'll be a squiggly line that goes up back and forth this way, and it'll have a million times that it fails the vertical line test. Okay, so bottom line, we can only flip this part of sine, and therefore that's the only part that has an inverse. All right, so how many answers are there? It all depends how many you want. There's infinite answers. Do you get, usually we say, to stay in this yellow box, which was that's where sine goes from 0 to 2 pi. Inside that box, do you get I pick up another answer? Oh, now there's 2 answers. But not if it's inverse trig. If inverse trig, you're in the green box if it's inverse trig. Normal is between 0 and 2 pi, and that means we have 2 answers. But really, aren't there infinite answers? Doesn't it keep touching the line? So there's infinite answers, and that's what I have to teach you today, is that if we don't put any restrictions on it, if we don't say between 0 and 2 pi, or if we don't say inverse trig, because if it's inverse, instant restrictions. If we don't say that, if we just want all the answers, how would we even say all of the answers? Well, first of all, we know this one's pi over 4. And the other one, that would have been down here. If we wait, no, where else is sine positive? Up, oh, sorry, not down there. It would have been up here. Hold on. There. Would have been up here is where the other answer would have been if we didn't have those restrictions about inverse trig. And we would have had this answer, 1 root 2, and this is negative 1, and then this would have been 3 pi over 4. There would have been 2 answers if it hadn't been inverse trading. Here's where 3 pi over 4 would have been. Do you get how I could have had 2 answers if I wanted them? Okay, now here's how you'd get all answers. Instead of just saying theta is pi over 4 and theta is 3 pi over 4, I now say plus you can pick up more answers if you add the period. 2 pi k. What's the k? That means you can do it any number you want. If you want to do it times 1, go ahead, do it times 2. 2 sets of 2 pi, 3 sets of 2 pi, negative 1 sets of 2 pi. It could multiply by any constant. So plus 2 pi k, if you throw that onto your answer, you've got the unlimited answers. Let me show you what that really looks like. I'm going to now use a black line because it'll stand out because my axes were black, but everything else has been colorful. Do you get if I add 2 pi, it ends up right there? Do you get how this one goes 2 pi over, goes to right there? So it'd be pi over 4 plus 2 pi. What about this one though? That goes over 2 pi and ends up right there. Do you get I can keep adding 2 pi though to both answers? So that's why you have to have the plus 2 pi k, because k can be any number of times. So that's how you can get unlimited answers, or all the answers. Now you might say, okay, but Mr. Surver, sometimes they had a weird thing like plus 2 pi k over 3. Why were they doing that in the key last night? Because sometimes the period wasn't 2 pi anymore. Do you get if the period isn't 2 pi, you're not going to add 2 pi? If the period's 2 pi over 3, then you'll add 2 pi over 3 times k. So what if, just remember this from last night? Do you remember how sometimes there was like a 3 theta here? If there was, I'm changing the problem, so don't just throw it into your work because it'll all of a sudden make no sense because there isn't a 3. But if there was a 3, do you get that then we would multiply everything by 1/3? All right, and you'd have a 1/3 here, and a 1/3 here, and a 1/3 here, and a 1/3 here, and a 1/3 here to cancel it, and a 1/3 here to cancel it, and now I'd have my answers, and they'd look like 2 pi k over 3. That's what we're going to do right now. So everybody write this one down. Cosine of 3 theta is equal to negative 1/2. You're going to realize pretty quickly that that's the same as a problem we did earlier, except now it's got a 3 on the inside. So let 3 theta equal u. And now the problem will be cosine of u, not 3u, cosine of u is equal to negative 1/2. Well, you already have those answers. No reason to reinvent the wheel. Go look them up. From earlier, just a few minutes ago, where were those 2 answers? Isn't it 3 pi over 4? Or no, was it pi over 4? What were the two answers?
Well, it was 1 over root 2, wasn't it? This is just 1 over 2.
Oh, you're right. We are going to have to... Yep, I did this in a different hour. I did this problem. Like I had used cosine of theta equals negative 1/2. I didn't in your hour. You're right. So you're right. I did square root of 2 in the other example. So this one, you better actually do this one. You'll get your answers. Just remember that when you swap the u back in, you got to put the plus 2 pi k in there. All right, so catch up to me. If I get ahead of you, I'll pause and then I'll let you catch up. So cosine's negative. Yeah, this is definitely a different problem because now this one's 60, which is the same as pi over 3. And I'll have two answers. One for there and one for here. And you'll have u equals this and u equals that. Sam, what did you get? U equals, hopefully they're sets of 2 pi over, or sorry, sets of pi over 3. And now we're multiplying by 1/3 at the recommendation of one of our kids here. 1/3 here, and a 1/3 here, and a 1/3 there. And 3 and the 1/3 cancel, so it's just theta equals 2 pi over 9, because 3 times 3 is 9, plus 2 pi k over 3. That's why it isn't just plus 2 pi k. You know that over 3? Look at, in the problem, there was a 3 right here. Remember how the period, you divide by that number? You know, you take the 2 pi and you divide it by 3. That's why this is 2 pi k divided by 3. All right, this other one solves down to theta equals 4 pi over 9 plus 2 pi k over 3. The new period is not 2 pi anymore. It's 2 pi over 3. So there's my two answers. That one and that one. And now I hope you understand we just gave all the answers. If I had just wanted them between 0 and 2 pi, I could have left off the 2 pi k thing. If I wanted this to be inverse trig, you only get one answer because we have limited to such small pieces of graph that there'll only be one answer in there. Okay. I hope you feel like that made sense. Now, I'm going to give you one last one. Yep, we still have time. And let's see if you can take this one. Sine of 4 theta is equal to negative 1 over root 2. Is this inverse trig? Do you see an arc or a negative 1 power? No, so it's not inverse trig. McLaren, what are you going to let 4 theta equal? Good. Sine of u equals negative 1 over root 2. Evan Olson, what quadrant are we in? Evan's gone today. I should be more careful who I call on because almost everybody's gone. Van Wyck, what quadrants can we be in or can't we be in? I'm fine with either. These would be places that sine would be positive, so they're out. You're right. Now I'm going to draw a triangle here. Opposite, hypotenuse. You know this one? You're right. It's 1. Close. Most common mistake in circle trig. Negative 1, okay. Now we know this is 45 degrees, but we can't say 45 degrees. And we can't even say pi over 4. Because it's all the way around to here, which is a bunch of pi over 4s. What is it? Is it 4 pi over 4? Yeah. 5 pi over 4. Good job. Limburg, what's the other one?
It's in the this is quadrant or quadrant 4.
Okay. And instead of 5 pi over 4, it's got to be more pi over 4s.
Yep, 7 pi.
7 pi over 4. And why can't I just go like this? U equals 5 pi over 4, and u equals 7 pi over 4. Wilson, what's wrong with that?
The 2 pi k.
Why do I have to add that?
Because you weren't given like only between like 0 and 2 pi.
Yeah, there's no restriction on how many answers I have, so I got to say plus 2 pi k, because there are lots of answers. And why can't I be done there? Rosenstein, what do I do?
You have to get theta by itself.
So you replace the u with a what?
4 theta.
And then you divide by what? I'm going to choose to multiply by 1/4. Notice I even do it to the 2 pi. Why? Because this thing does not have a period of 2 pi. It's got a 2 pi divided by 4. That's why we have to do it here and there. Final answer, theta. 5 pi over 16 plus 2 pi k over 4. Could you reduce that? Yes, and that would be good. Pi k over 2. And the other one, theta equals 7 pi over 16 plus 2 pi k over 4. It'll reduce the same way. Pi k over 2. Boom. That's some heavy-duty math. If you think I made a mistake there, please say something. But did anybody else get that same answer before I did? That would be the best way to check me. All right, good. A lot of people did. Do you see why we say plus 2 pi? Good. Why wouldn't we just leave it as plus 2 pi? Because sometimes the period isn't 2 pi. Because we've changed it. So it might be 2 pi over 3. Okay. So now, the rest of the hour, the only thing assigned is I recommend that you go back and do a few homework problems where you take the answers you had, you know, like you were getting things like 5 pi over 4 and 7 pi over 4, but you weren't doing this plus 2 pi k thing. You know what I mean? So add whatever the period is. If it was 2 pi, great, 2 pi k. If it's 2 pi over 5 is the period, well then add 2 pi over 5 k. All right, so just fix those plus 2 pi k things. And you're going to take a top 20. Why am I going back to the top 20? Number one, because it's really good for you. This is one of the things I do to add on to just normal teaching. I try to add a couple things. One, I try to make you better at your basics than anybody else. I'm kind of proud of that. And by pounding on this, trying to get you up to like a 19 out of 20 on it, I'm trying to help you rock your ACT someday. Okay. Number two, I also try to add some math behind it. So try to show you some math in the real world, like cryptocurrency going up times 11 in a couple months. You know, it's interesting, I think. So, all right, I'm going to stop the video at this point.